Thomas that will talk about Gerrit on Kubernetes. We're going to have a lot of Kubernetes talks this afternoon.
So let's get started with Gerrit on Kubernetes. And I first have to make a confession. At SAP, not all of our Gerrit instances are highly available yet. So that's a bad idea. We heard that in a lot of talks in the summit, and that's why we also want to change that. But doing that, even with all those tools that were developed in the last few months and years, which were also already mentioned during the summit, this is hard to set up. It's probably even harder to operate, and we wanted to have some tool at our hands to help us doing that. So what do we want to achieve? We want to have a straightforward way to deploy and operate Gerrit in an automated, scalable, highly available, and self-healing way. And yeah, in the end, we also, of course, want to share that with the community, so it should not only fit what we need at SAP. To that end, we decided to go to Kubernetes, and during the last months, we developed an operator to manage Gerrit instances in Kubernetes. So what is an operator? An operator is a software extension to Kubernetes that makes use of custom resources to manage applications. And it does that by using the typical control loop used by Kubernetes itself. So it listens to custom resource updates or any resource updates in your cluster. And then if a client updates such a custom resource, it will compare the state that the client requested in the custom resource with the current state of the cluster, and then adapt the cluster state to match the requested state, and the loop begins anew. And with that, you can do quite some powerful things in Kubernetes, like, for example, setting up Gerrit using the Gerrit operator. But let me first start with some technical details about the Gerrit operator. The Gerrit operator is completely written in Java. So usually most operators are written in Go, but we decided to go with Java because that fits in the Gerrit community better. There are a lot of Java developers, of course. And we make use of the Fabricate Kubernetes client and the Java operator SDK to make this work. And we also provide a Helm chart to deploy the Gerrit operator in a straightforward way. So the Gerrit operator itself supports 5 different custom resources. So there are 3 low-level custom resources here, which are not meant to be installed directly by the admin, but will be managed by the operator. Those are the Gerrit custom resource, which represents a Gerrit instance in your cluster. There's the receiver custom resource that represents an Apache server that can be used for receiving replication pushes from a remote primary Gerrit. And then we have the Gerrit network custom resource that represents the configuration of network routing in your cluster in concerns of Gerrit. But what you should actually use to deploy Gerrit into your Kubernetes cluster is in the Gerrit cluster custom resource, because in that resource actually combines the 3 other custom resources and makes it even easier to set everything up and reduces the number of configuration options needed. And then we also have the Git garbage collection custom resource, which represents Git garbage collection job, so that the operator can also take care of that. So we named this one custom resource a Gerrit cluster. And what do we mean by that? So for us, the definition of a Gerrit cluster is a set of scaled and specialized Gerrit installations that serve the same set of repositories and that uses a single point of ingress for client requests. So even if you have multiple different Gerrit instances in your cluster, some of them might be primary Gerrits or Gerrit replicas, clients should not be aware of that. Their requests should be automatically routed to the respective instances. At the moment, we support, in principle, 5 different combinations that you can run in a single Gerrit cluster. So you can have a primary Gerrit, so one stateful set of a primary Gerrit with up to 2 pods at the moment, or you can have a Gerrit replica with up to n pods, and the same is true for the receiver. And then comes what I would call the canonical setup, so the intended setup that is to have one primary Gerrit stateful set with 2 pods and one Gerrit replica stateful set with up to n pods. And of course, if you have a primary sitting somewhere else, you can also install a receiver together with the Gerrit replica to serve fetch and clone requests. So how does that look then in your cluster? Something like that, that we have the primary Gerrit and we have the Gerrit replica here, and they share the Git repositories in a shared file system. So why do we want to split the primary Gerrit and the Gerrit replica? That's something that we already do at SAP outside of Kubernetes and where we had quite some good experiences with, because it allows us to optimize the primary Gerrit and the Gerrit replica for their different workloads that they see. So that mostly the highest impact that we saw was on Java garbage collection, because on the Gerrit replica, which is serving fetches and clones, we can live with longer stop the world pauses, because whether your fetch takes 10 seconds longer or shorter, you probably won't notice. But if your page in the UI takes 10 seconds to load, you will notice. Also, we noticed that we get better performance on the primary Gerrit, especially when serving the UI, because robot systems did not impact the performance of the primary Gerrit anymore during high load times. And also the Gerrit replica can just more easily be scaled because it's read-only. So the typically high workload of Git fetch and clone can be distributed among more different processes or pods in terms of Kubernetes. So let me get into more detail how the Gerrit replica looks like in a Kubernetes cluster. So here, as I mentioned, we have a stateful set running multiple pods with the Gerrit replica inside. They all access in the Git repositories via one shared file system, but all the other side components, like for example the groups index, are not shared, so each pod will have their own side otherwise. It is unfortunately not as easy for primary Gerrits, because there, if 2 primary Gerrits try to update the same ref at the same time, we of course could see some conflicts. So we currently solve that by making use of the high availability plugin. So here, using that, we can deploy up to 2 primary Gerrits that share the Git repositories via the same shared file system that would also be used by the Gerrit replicas. This file system does also contain other data like the web sessions that need to be shared between those Gerrits. And of course, those Gerrits also need to know about each other and communicate with each other. And for peer discovery, we use JGroups. That's a feature that's already available for some time. And we now added support that JGroups can find its peers asking the Kubernetes API server. Yes, and knowing its peers, it can then forward index updates, cache evictions, and stream events, so that changes happening on one primary Gerrit can also update the state on the other Gerrit. And I already talked about possible conflicts if there are concurrent ref updates on the same ref. And we use the global refdb to solve that. So when a ref update happens in one Gerrit, it will log the entry for that ref in the global refdb, perform its ref update on the file system and inside the refdb, and then unlog. If the second primary Gerrit would try to update the same ref at the same time, it would fail because it can't get the log. And thereby there should be no conflict or split brain situation turning up. Okay. But now having 2 different kinds of Gerrit deployments in your cluster, you somehow have to decide where to send requests coming by the client. And in our definition, we already said we don't want that the client knows about the internals of the Gerrit cluster. So request routing should happen automatically, and the operator will take care of that. So currently, the operator supports two ingress providers. That's the Nginx ingress controller and Istio. And very soon, it will also support Ambassador Emissary. These changes are already under review and were done by Mr. Shakir from Arista. So what will the operator do? That depends on what you have installed in your Gerrit cluster. So in the easiest case, you just have a single deployment of a primary Gerrit or Gerrit replica. Then there will be no special routing logic here. All requests will be sent to that Gerrit instance. But if you use the schema that I suggested, so having a primary Gerrit deployment and a Gerrit replica deployment, the operator will take care to configure the ingress provider with some routing logic. So here, we first differentiate whether SSH or HTTP is used. If HTTP is used, there will be a check whether it's a git fetch or clone. If that isn't the case, it will be sent to the Gerrit replica, and otherwise all requests will be sent to the primary Gerrit. Of course, inside the primary Gerrit or Gerrit replica, there might be multiple pods. In that case, it will just be distributed on a round-robin basis. For SSH, the situation is a little bit more unfortunate because load balancing of SSH request happens on network layer 4, where we can't see whether it's a git fetch or clone request. So we don't know where to route a single request based on its contents. So here we have to use different ports. So using port 29418 in this example, the request will be sent to the primary Gerrit, and using port 39418, it will be sent to the replica. That's unfortunate because the client then has to know the internals of your Gerrit cluster, and that's something that we wanted to prevent. And it requires manual setup for the client. That's also why we highly suggest to only support HTTP if you move to scaled instances in Kubernetes. And we also have the case where we don't have a primary Gerrit, where we use the receiver to receive replication pushes from a remote primary Gerrit. Here, SSH requests will all be sent to the Gerrit replica since the receiver doesn't support SSH. And for HTTP requests, we check whether it's a git push, or if it's using the admin API, meaning creation or deletion of a project. If that isn't the case, the request will be sent to the receiver. Otherwise, they will be sent to the Gerrit replica. Note that the receiver uses a different ACL than Gerrit, so users are not able to just push to the receiver. Okay, and then we have the last component here, the git garbage collection. And here the operator also supports you setting this up. So if you apply a git garbage collection resource to a cluster, you have to give it a schedule. So here it would run every 6 hours. And if you don't provide any specific repository to work on, you will create a default git garbage collection job that will take care of all repositories in your Gerrit cluster. But of course, you likely want to git garbage collect all users a little bit more often than every 6 hours, considering NoTB. So let's create another git garbage collection job where we say this is specific for all users. And that should run every 15 minutes. So if you do that, the operator will automatically detect that there's a specific git garbage collection job for all users and will exclude it from the default job, so that there are no two jobs working on the same repository at the same time. Actually, if you now would try to install yet another git garbage collection job that also references all users, this custom resource would be rejected when you try to apply it, so that there can be no conflicts. If you now delete this git garbage collection job for all users, the operator will automatically add the all users repositories again to the default git garbage collection job, so that it's continued to be garbage collected. Yes, with that, we have all the components of a Gerrit cluster quickly discussed. There's, however, one other important feature of the operator, and that's the configuration management. So some configuration in Gerrit or in its plugins is actually predetermined by the cluster infrastructure. So the case that you use Kubernetes and the Gerrit Operator setup. One such example is in the listen URL. Here, the KLS Gerrit project actually hard codes the port that's used in the Gerrit containers. So that will always be 8080. And also, since we are using an ingress, so a proxy, we always have to prepend the proxy to the protocol. And TLS is also configured in the ingress provider. So either we have to set it to HTTPS or HTTP, depending on the ingress provider. And to do that as an admin, when you try to set this up, you have to have a lot of internal knowledge about how the Gerrit operator works. But the operator already knows all this. It has all this information, and it should take care of this itself. And that's actually what it is doing. So I would suggest not to set the listen URL at all, and that's also true for other configuration options, because then the operator will set this configuration for you and provide it to Gerrit, and you don't have to take care of that at all. If you set it anyway and you set it to a value that's not supported by the Gerrit operator, the custom resource will be rejected, and you will be notified that there is some wrong configuration in your custom resource. But if you set it to the correct value, so the value that the operator would expect, of course, then the custom resource would be accepted. Okay, now we have discussed all those features and that the operator provides. Let's go into how to deploy this whole setup. And there are some prerequisites that have to be met in your cluster. So you have to have some kind of provisioner that provides read-write menu volumes, means shared file systems, as for example, NFS. Then you need to have some ingress provider that we support. And if you plan to scale primary Gerrit to more than one instance, you also need a database for the global FDB. And here the operator currently supports Zookeeper and Spanner. Note that this list of supported ingress providers and databases can be extended quite easily. So if you, for example, plan to use DynamoDB on AWS, it's fairly easy to just add support to the operator for that. Okay, let's have a look on how the custom resource looks like for a Gerrit cluster. So this is typically for Kubernetes a YAML file, which contains some metadata. And then we have the spec, which is currently distributed among 6 categories. So first, you have to configure some details about how to get the container images that are being used in your setup. You have to configure the storage to be used, the ingress, the RefDB. You have to provide a list of Gerrit installations, and that should be part of that cluster. And optionally, you can also set up a receiver. In more detail, the container image configuration looks like that. There are 2 important things here. If you use a private registry for your container images, you have to provide an image pull secret. And the operator in general doesn't manage secrets. The reason for that is that you would have to put your secrets in plain text in your custom resource, and custom resources in a Kubernetes cluster are not as protected as secrets are. That's why you have to create that secret yourself and just reference it here by name, and then it will be configured in all workload pods. Also, the operator enforces you to use the same version in all the container images. Those container images are actually provided in the Kubernetes Gerrit project itself, so the same project managing the operator. But yeah, you have to use the same container version to ensure that there are no incompatibilities if you start the setup. Then for the storage, here we mainly have to configure 2 different types of storage. One would be using just block storage to store the side components, and yeah, we already discussed the shared file system that we need to have access to. Yeah, for the ingress, you can even optionally disable the use of an ingress. That's mostly useful if you either don't want to expose it to the internet yet, or you want to configure it yourself because you use an ingress provider that's not yet supported, and you can just disable it. You have to provide the host name that's used by the clients, and optionally you can enable TLS and SSH. Yeah, for the global FTP, you have to decide which database to use, and you have to configure how to connect to this database. Note that, at least as of now, the Gerrit operator won't access in the database itself. It will just configure all Gerrit instances in your Gerrit cluster to use in that global FTP. That's just done to ensure that all Gerrit instances actually use in the same FTP, since they are also serving the same set of repositories. And then finally, you can get over and configure the Gerrit instances. Here's an example. We configure primary Gerrit, so it's running in mode primary. There's also a mode for replicas, and we already have plans to add some more modes for more specialized Gerrit instances. Since it's a primary Gerrit and we want to scale it up to 2 pods, we also need to provide a service account. That's required so that J groups in Gerrit can actually contact the Kubernetes API server and get information about other Gerrit pods. For that, it needs the correct permissions, and we don't want the operator to set up these permissions because that would basically give admin rights to the operator in your cluster, and that's something that you don't want to do. So you have to set up this service account yourself and then provide the name of the service account that Gerrit should use. And then you can configure some plugins to install. So either those plugins are available in the Gerrit WAR file, then you can just have to give the name of that plugin and it will be installed. Or you can download it while Gerrit is starting up by providing an URL in the SHA-1 of the jar file. There's also an optional cache for the downloaded artifacts, so that you don't have to re-download them every time you start up Gerrit and might run into issues if the URL is not available anymore, for example. Note that plugins that are required by the setup, like the health check plugin for the liveness probes or the high availability plugin, if you scale Gerrit, those will be installed automatically from the container, so you don't have to configure them here. However, if you want to, you can, for example, override the version of that plugin by providing a different download location. The same can also be done for lib modules. Then you can also provide the set of configuration files that you need. So of course, in the Gerrit config, but also for each plugin, all files that you provide here with the name as the key and the content as the value will be mounted into the etc directory of the Gerrit sites. For the secure config, you again have to provide a separate secret and just reference it here with name. The reason is again that the operator doesn't want to take care of secrets in the custom resources. And if you need it, you can even enable debug in your Gerrit instance. Okay, and with that, I would also like to show you how this looks live in action to install such a Gerrit cluster. And I hope you can now see my terminal here on the left side, and on the right side there's my editor, so you will also see some of the resource files when we apply them. And here in the lower left you can see a representation of the cluster I will be using. So here we already have installed the prerequisites. We have an Istio installation available. We have an NFS provisioner, and we have Zookeeper installed for the RefDB. So let's go ahead and install the operator itself. So we need a namespace to contain it. So we've applied it and the namespace was created. No, nothing is running in there yet. We need to set up some credentials for the container registry. And then we install the Gerrit operator using its chart. So actually there are two charts. The first chart will install the custom resource definitions, and then the other chart will install the Gerrit operator itself, and they are dependent on each other, so you just have to install it once. But since the chart is currently locally, I first have to install the CRD chart as a dependency to the main chart. Then I can install the Gerrit operator chart. And here you can see how this will be configured. So you just have to provide the coordinates of the image you want to use for the Gerrit operator's container image. And you have to choose which ingress provider should be used. So this is an operator level configuration. So in this case, we want to use Istio. So let's install that. So here the pod is starting up. We can also check the logs. There it's starting. Everything seems to look good. So I was pretty lenient with the liveness probes, so it will take a few seconds until it's marked ready. So now this isn't the case. And now we can start installing the Gerrit cluster itself. So let's move back here to the namespaces, because the first thing is that you will create a namespace for the Gerrit cluster itself. And there it is. Nothing running in there. Then we again need to apply the secret with the container registry credentials. And then, as I mentioned, we need to create a service account. And here you can see we just give it the rights to get and list pods in our cluster. So let's apply that. And next, we need to provide the secret configuration for Gerrit, so a key store, the secure config, and some host keys for using SSH, for example. And having that done, so I can also show you both secrets for Docker and secure config are available. We can install the Gerrit cluster custom resource. So the configuration here is basically what I already showed you in the presentation. Here we want to install a primary Gerrit with 2 pods and a Gerrit replica with 3 pods. So let's do that. And here you can now see the pods are starting up. This will take some time. So let me show you something else. So here you see no healthy upstreams yet, so we have to wait. But I have a second cluster already available with this setup being installed. So 2 primary Gerrits and 3 replicas. And that's actually being used. So a lot of random garbage created by some simulated clients here. So we can actually see that this is actively used, also with the replicas. And here with the replicas, we also see they're used to be cloned and fetched. And if you just check the primary Gerrit, there's no data. There's no data because there are no fetches and clones reaching the primary. They're all routed to the replica itself. And if we look at the statistics of the clients, you can see there is a small percentage of requests that fail, that still fail, mainly query for change files. But a lot of those requests are going through, and these are currently about 18,000 requests per hour. So it's hit quite heavily. Okay, so let's check whether our cluster is ready. So you can see it's still starting up, but we have a primary pod and a replica pod already available. So we should already be available. So let's, of course, sign in. So let's go to the Gerrit main UI. So it's ready. So we can now also create a repository, for example. So it's working as intended. So we have installed a Gerrit cluster consisting of a primary Gerrit and a Gerrit replica. I want to show you what will be coming up next. So we are close to the release of version 1.0. We are planning to release that end of October, beginning of November. Until then, we still want to add versioning to custom resource definitions. So currently, if we change something in the custom resources, you would have to reinstall everything once, which means downtime. And I'm already working on providing migration paths for that situation. Then we want to use JGroups for peer communication. So currently, we are still using the REST API to communicate between Gerrit instances. But Sasha is already working on a change that introduces communication using JGroups. We also want to provide a method to collect logs. So currently they are stored on the shared file system, but it's of course tedious to look at them. So we want to provide the possibility to collect them using an agent like FluentD, for example. And yes, as I already mentioned, the ambassador support is also already in progress, work in progress. But we won't stop there. We have plans for after 1.0. So first of all, we want to support to scale primary Gerrits to more than 2 pods. This is likely currently just limited by the JGroups implementation, which still has a hard-coded assumption that we can only use 2 primary Gerrits. So this should be straightforward to support. Then we want to automatically reload plugins instead of restarting all pods. So to improve availability or the risk of doing changes in the plugin configuration. One thing that we at SAP definitely have to take care about is to externalize reindexing, especially on schema upgrades. And the reason for that is that for our main Gerrit, it takes 2 weeks to reindex the change index. And we, of course, can't do that in pods that serve client traffic. So we plan to have a specialized Gerrit instance in the cluster that takes care of updating the index before applying it to the Gerrit instances used by the clients. And we would like to support auto-scaling, especially for the Gerrit replica. Then for version 2.0, we also already have quite a lot of ideas. So we would like to add multi-region support, then using the multi-site setup. We want to remove the dependency on shared storage, especially if we see that we get NFS-related issues. This would most likely also use the multi-site setup. So instead of sharing repositories using NFS, we would share them using pull replication and the other mechanisms that multi-site provides. We would further like to use the centralized shared index instead of having a copy of the index in each pod, and to do the same as well with the cache. Another thing that we discussed is sharding based on repositories to be able to optimize the Gerrit instances based on what repositories they serve. This is especially interesting for the replicas, so that we could have dedicated replicas for large mono repositories, for example. And we would like to make Git garbage collection smarter so that it reacts on metrics instead of just running on a schedule. And there was already another talk in the summit by Ponch, who was also started working on that. So this will definitely also be interesting for us. Okay. So for those of you who already had a look at the K8s Gerrit repository, you might know that it originally started out with providing a Gerrit and a Gerrit replica Helm chart, so not an operator. And I didn't mention those at all so far. The reason for that is that at least from the side of SAP, we have stopped feature development for those charts because we think that the operator isn't the way to go. It's just more flexible and more powerful, and we currently can't provide support to both. But that doesn't mean that we will remove them. So if anybody is interested into continuing the support because they prefer to use just a Helm chart, then those Helm charts are definitely out there for adoption. If you're interested, please just contact me and we can set something up there. Yeah, and just in short, what are we planning with Gerrit on Kubernetes at SAP, or what are we doing with that? So we already have one Gerrit replica deployed using the Gerrit replica Helm chart, and that serves some of our largest repositories for more than 3 years, and it really runs very stable. We are really happy with that. And that's also why we made the decision to move our other Gerrit instances, also primary Gerrit installations, to Kubernetes. And this is planned for early next year. And we are already in the progress of setting up our testing landscapes to get started with that. So if I could pique your interest into that project, feel free to have a look at the repository. It's called K8s Gerrit and is hosted on Gerrit Review. The container images are deployed to Docker Hub. We now also have a component in the Gerrit issue tracker. So if you have feature requests or bugs, just post it there. You can, of course, also contact us on Discord. And of course, contributions are very welcome. And with that, I'd like to thank you for your attention. And if you have any questions, please post them. Yeah, that's something that we already use for a long time, originally in Docker. So it's basically an Apache server that serves a set of CGI scripts. One is just the official Git HTTP backend, so just serving Git requests. And the other one is a script that simulates the parts of the Gerrit REST API, the parts that are used by the replication plugin to replicate creation and deletion of repositories. So basically, you can just set it up and configure it in the replication config of your primary, and you can use it to replicate your repositories with push replication, as you would to any other Gerrit, for example. So far we have little experience with having that under productive load. We are just starting out testing that. So it's hard to say yet how well it will scale. What we currently see, so what I showed in the demo, the file system was just the cheapest one you can get on GCP. So it's just HDD with basic performance levels, and it worked quite well, at least on repositories that are just filled with random stuff, so not large monorepos. So we will definitely spend a lot of time in the next few weeks and months to do performance testing. But at least for the replicas where we already host a large monorepo, we know that it works very well. So we run 4 to 5 Gerrit replicas that share the repositories via NFS, and there we don't see any issues. The upgrades in K8s Gerrit, if you are highly available, are rolling updates. So basically, Kubernetes will first of all take care to not send requests to the pod that is currently being updated. So that's not ready. So it's basically acting like the load balancer that Luca also described in his talk about the 3.8 upgrade. For us, the main issue in that regard is actually schema upgrades in the index that, as I mentioned, can take up to 2 weeks for us. And that's why we plan to have this separate deployment that runs reindexing for you, while the client-serving Gerrits are already updated, but still use the previous schema version for the index to serve requests. And only if the index migration is ready by the reindexer Gerrit service, let's call it like that, then it will be then this index will be applied to the client-serving Gerrits, which via rolling restart. What happens if both of those Gerrits receive a push for the same, that causes a ref update on the same ref? So one client pushes a new patch set to one change and another client to the same change, which would cause a ref update to both meta refs. And they might end up on different Gerrit primary nodes. So if they would try to do the ref update at the same time on the file system, we might see conflicts. And to prevent that, we use global FDB to lock the reference.